Okay, ladies, gentlemen, I would like to calculate an inverse function for number 10.2, number 11, which, it should be noted, is a good example of a place where a bubble diagram will not help you as much as it could. Right? Like, it would be nice if I was able to write down an easy bubble diagram and then back out all the steps, right? But why doesn't m of x equals 1 over x minus x lend itself towards bubble diagramming in general?
Not a composite function.
Yeah, it's not obviously a composite function.
Yeah.
You guys see that? Like, I can't think of 2 steps to make this sucker work. It seems like there's just 2 places you put an x.
Right.
Right? So, in those cases, you can play with some arithmetic. Okay? And the bubble diagram thought will still help you. You just have to do a little more thinky bits. Thinky bits. So over here you have an x, right?
Yeah.
That x gets turned into an m, right, by the formula you have.
Yeah.
Right, an input goes to an output, right? So I would like to back that process out. I would like to think, if I had an m, how would I get the x that goes with it? You guys see that? So I'm going to just assume I know m. I'm going to think that's a number.
Sweet. That's great.
Right? Like, if I had a number m, and I had this, how would I solve this?
First, I add x.
Okay. So we add x to both sides. So we have m plus x equals 1 over x.
Multiply x over x.
And then you multiply both sides by x.
Yes. Oh, no. X. Oh, you want to subtract that first?
What?
Nothing. We're going to get nothing.
What do you want to do, Mika?
No,
That exactly what it was.
No, keep doing that.
Why?
Levi was trying to do x over x, and he was just trying to make it more complicated.
Okay.
Just multiply that.
Yeah, that's what I want. Okay.
So if I multiply through by x, I got mx plus x squared equals 1, right? Now what am I trying to find? Yeah, right now I'm trying to find x.
Oh.
Oh.
Well,
Well, then I divide by m.
oh yeah.
No, factor first. That's.
Okay, so you think I shouldn't have multiplied it out?
Yeah, because then just do divide by m plus x, so x equals
And you
1
divide
over
by
x.
m plus x, and you multiply by x again.
That get me back to there.
X equals 1 over m plus x.
Just want to get x by itself. So for the
No. Yeah, so I want to get x by itself, right?
Yeah.
Divide
Yes,
by
yeah.
m plus x.
Divide by m plus x will get me not x by itself.
Will give me an x by x.
It'll give me an x by itself, but it'll still have an x in it.
Right.
Yeah.
And then can't you just?
Okay, what the heck? Let's try that. It'll be fine. So if we multiply through by 1 over m plus x, right, we'll find out x is 1 over m plus x,
Right. And then just multiply.
right? But then we know what m is. No, wait. We know what x is. You guys see that? I'm going to teach you a crazy trick just because I have the opportunity to.
Oh, you're gonna put n.
You know what x is. It's that stuff. So you can put this stuff in for x.
Great.
Yeah.
So you know that x is 1 over m plus 1 over m plus x.
Perfect. So then you multiply by m plus x, basically.
Well, no, I mean, you know what x is. It's this stuff. So you just put that in for that x now.
Right.
Oh no.
Wait, what are you? It just goes on and on.
It just goes on.
It'll be fine. Don't worry about it.
What? It's just continuing.
It'll be fine. Don't. We're just gonna learn that it's like.
Why? I think I'm having a nightmare.
What's that?
What?
Wow.
Exactly.
The funniest thing about this is that's actually a thing.
Oh my god.
That's a thing called a continued fraction.
Oh my gosh.
There's continued fraction calculators. You could cram M in for this.
Wow.
You get stressed out by two fractions. Infinity fraction is not calming you.
Yeah, like how does that even work?
It works by some Calc 2 stuff. So in Calc 2, you make a thing called an infinite series, and this is an example of a kind of subset of infinite series. So
When did you
this is
use
a little outside the scope of the course. Number theory, for one thing.
But I guess that's not my question. When is it like functional? Like where do you apply it?
I actually wrote a PhD thesis on a number that looks a lot like this.
Wow. What was that relevant? What was your PhD thesis on?
Complex dynamics.
Okay. So, you used
So fractal geometry.
fractals. that
So
answers
these
my
are
question.
extremely relevant to fractal
Okay.
geometry. They're extremely relevant to number theory.
Makes a lot of sense.
So number theory basically boils down to cryptography for you at, in the place you guys are at in your math journey. So continued fractions get used there. They have some uses.
Understood.
But that's probably not the best answer for, like, that's not what the back of the book has, right? Probably not. That, in my defense, that is a perfectly mathematically valid answer,
So would you accept that on the test?
and the one I'm going to circle.
But how do we do it how the book wants it?
Oh, you guys want to do it the way the book
Yes.
does?
Wouldn't it
Well,
be-
that's
if you
boring.
want- so with your x.
Okay,
equals
so the way the
1
book does it is less interesting.
So where did we go off the rails in this whole thing?
Probably right here.
Okay, sweet.
So I wanted to solve for x, right? I had here a quadratic in x. You guys see that?
Yes.
So just subtract.
You can subtract 1 and plug it in the quadratic formula,
So it is plus or minus.
right? So, and that's not extremely satisfying, right? Because that would kind of imply it's not an inverse function, it's like an inverse idea.
Mm-hmm.
Whereas this would sort of suggest that this is in fact an inverse function.
Mm-hmm. So with your x equals 1 over m plus x, why can't you just multiply by x and get x squared equals 1 over m and then square root it? Plus or
So you
minus.
still have an x in the right hand side.
You would? But
Yeah.
then don't they cancel each other out?
You just do an operation.
So-
and do it.
What you want to do is ultimately get the x's out of this thing, right? And so the best way to do that, I think, is to take that one, this level right here. So I had x squared plus mx minus 1 is 0, right?
And then solve it that way?
These don't lend themselves to picture.
And that's their practice.
So, this guy,
Yeah. X plus 1 is
A is 1, B is,
One.
but
Oh, a squared plus b squared equals, no, never mind.
It's
So
one.
it's one. It's
M.
m, and C is
Negative 1.
negative 1. And then you can cram this in quadratic formula. So you get negative m plus or minus the square root of
Oh my god, I don't remember this.
m squared minus 4 times
Four
a
times
times c.
A, C.
Plus 4.
So plus 4 over
2a, so 2.
2.
With that simplifies pretty easily. Because you get an M, and then you get 2.
Are
Right?
you false rooting, kid?
I don't know, maybe. Am I?
Yeah, you're false rooting.
Ah, Jesus, don't listen to me.
So be careful. You do not do as Gabe does.
Yeah, don't do it.
And try to hit this with the square root and that with the square root. Because you need the square root of all of this stuff.
Yeah.
And it's stuck together with addition. Right? So I think this is the best you can do. This, it should be noted, is not an inverse function. So if you write x of m here, probably should make some kind of concession like this is not a function. You guys see that that's not a function?
Yes.
You see why it's not a function?
It wouldn't pass the line test.
Yeah, it doesn't pass the vertical line test because the plus or minus is giving 2 outputs for every 1 input, right?
Okay.
Which really kind of implies that this thing didn't pass the horizontal line test. Can I steal a graphing calculator from somebody?
As long as it's
Yeah, I'm a little
actually-
bothered because with 0, if x is equal to 0, we got a problem over there.
Yeah, I definitely have a problem when x is 0. You guys see Story's complaint?
Yeah.
You multiply both sides through by x. If x was 0, you just nixed your whole equation anyway, right?
But if x is 0, then your calculator would just be negative 1 equals 0.
Well, plus the top, you have 1 over x minus x.
Yeah, so if it's 1 over 0,
So it
it's
fails, fails pretty quick.
With a negative 1.
Yep, that would be a function that fails the horizontal line test right there.
Doesn't it fail if it's
So if you look very closely at the picture near 0, it fails the horizontal line test, which means once it has failed the horizontal line test, it's not going to have an inverse function, which is what's going on here. It has, in fact, a double branch, right? Because there's two options. Cool? Question, Steele? This is a bad question. Why did I assign you this one?
Would you accept the continuous fraction answer?
Yes.
I would definitely accept a continued fraction on the test.